Hi, welcome to the lesson about aggregations. So aggregations are one of the use cases, one of the implementations of stateful processing. In the easiest, I would say in the easiest, well, in the simplest terms, you can use aggregations for one column. And aggregations, there is no singular use case. You can use, as you can see here, different aggregations for the given group, which can be quite interesting. You can get different min, max, averages, whatever you want, which is supported by Apache Spark or your framework. But you can also use one aggregation and, for example, consider the outcome of this aggregation as an input for the next stateful operation. So there are different scenarios here. I will show you maybe the most popular one when the aggregation is the final output, and that is quite complex because, as you can see, we have different aggregations on different columns of the group. So here I'm using a 8 microbatch data source. I'm generating 5 rows per microbatch, and microbatches advances 1 second each time. And in the aggregation, so I'm later adding a label column for even or odd number. Later I'm performing a group operation on top of this label column, and I'm doing aggregates on each group. And in each group I want to know the whole number of rows, the mean value, the max value, the average timestamp, the min and the max timestamp. I'm starting now the job, and you will see that the results, well, they follow the data flow, because the data flow adds more data and increments the input, and typically we will retrieve here. We retrieve this in there. So we have a increased count number, the mean value remains the same, the max value is always equal to the last value sent by the rate microbatch data source, and the average is the difference between the mean, which never changes, and the max that remains, that increases in each microbatch. So that's for the execution. So we can see that it runs and there is no complications, but you may be wondering, well, we have these multiple aggregations, so maybe there is multiple data input reading, right? That's maybe your question. But if you check the operation, well, you can see that we are reading data only once. We are performing the aggregate because, remember, all aggregates are performed on the same key, so there is no need to shuffle data twice or read data twice. So we are doing this shuffling here, and local aggregations for each of the functions. As you can see, partial count, partial max, partial min, all this is performed locally before shuffling, and later the exchange node means that we are gonna to shuffle this data between partitions, so that all events for the same, all rows for the same grouping key are on the same partition, on the same shuffle partition, and later we are doing some kind of merge between all these aggregates. So that's for the real-time data, and later we read the state store, and we do the aggregation when we save the result back to the state store and write everything to the data source. So there is no such a thing like double reading, like double hashing, double shuffle, sorry. Everything is made in a single operation, and despite the cell impact on your processing is on the state store, because here you don't have the state entry for one aggregation, you have the state entry for multiple aggregations. Thanks for watching, and see you in the next lesson.